So if you pay close attention to my channel, you'll notice that I don't dive into agents often, and I don't create agent frameworks often. I have created a few agent frameworks, and they've been they've propagated a lot. I'll say that. And then so within this, I have developed what is now like my coup de grace as far as agent frameworks, and it's called ant colony swarm agents. I'm probably not going to touch agents again for a long time after this. So here it is. As an overview, ant colony swarm agents is an advanced swarm intelligence framework developed by Moonshot Laboratories under the MIT license. This project implements an AI-based swarm system where a queen agent governs worker agents, optimizing their performance through multi-round learning, stagnation detection, and strategy evolution. The queen dynamically adjusts strategies based on stagnation detection, enabling aggressive forced evolution, strategy fusion, and worker mutations. The framework integrates Fibonacci-based learning rates to enhance adaptive learning. There are so many frameworks that I've kind of like packed together, put into this overall to build out this framework, and like people that have given me like data that I've been working with along the way to build this out, that I can't acknowledge like everyone that I could possibly think of within this. But so I've laid out the framework, like the overview of the framework there. If something I said stands out to you, very likely I'm borrowing from something that we had conversations about, or that we've discussed, or that I want to acknowledge on that level. And then so diving into ant colony swarm agent specifically. So for the GitHub, if you want just the code, like you want to skip straight to it, it's here, no experiments whatsoever. If you want to know how I experimented, how I got here, and more about the framework overall, here it is. So essentially, the framework is designed, it utilizes swarm algorithms with a queen in the middle. And then the problem with swarm algorithms overall is so a lot of people don't know this, but swarm algorithms are like very orthogonal to HDC or hypervectors. And like a lot of like, they like, to me, they learn the same way. There's a lot of whatever mechanism goes on is like the same, because how hypervector works is you essentially it takes like the best probability, right? Like, or like, you know, like orthogonal probability of something, and you just it collapses to like a probabilistic state. And whatever that accuracy is, you can't really fine tune it past that. You can, but it's not going to move the needle hard, right? So if it collapses to like 80% accuracy, that's your accuracy. If it collapses to like 60%, that's what it is. And swarm algorithms have that same component to them. Like whatever the accuracy is that it collapses to, like it's like, I mean, and the optimal strategy that the swarm finds, it's not going to deviate from that, right? Like it's so hard to shock the system out of it. And so that's what I built this entire framework around, right? So you have these swarm agents, and they go through and they do, like, most of the time, they're going to do a good job. They'll do like 60, 70, 80% accuracy. But we want to fine tune it from there. And then so what I've done is I built essentially a queen in the middle of this, right? And the queen is just like flat out OP. The queen is the general. The queen has access to every strategy imaginable, every tool imaginable, every framework imaginable. The queen can do anything. Like the queen is the most overpowered being that could ever exist within this framework, right? And then I've finally dialed it to the point where the queen can and will control the swarm to update the swarm after it locks in on these strategies. So let me walk you through this. Starting off, like kind of the describing and going out the framework, right? I flat out like start going through kind of like this with the model, like pretending I'm the queen. Here's everything I would need to ensure I have total control, maximum optimization, and relentless accuracy improvement for my swarm. Core philosophy of the queen. The queen is the ultimate strategist. The swarm is my body, and I'll optimize it ruthlessly for maximum efficiency. Every decision I make is goal-oriented. I prioritize accuracy improvement above all else, even if it requires sacrificing stability. The swarm must evolve always. If improvement stalls, I will force change. 2. The queen's core decision-making systems. Reinforcement learning with force bias towards improvement. I maintain a queue table to store past actions and their outcomes. If stagnation is detected, I assign strong penalties to maintain strategy, action space, what I can do to the swarm. I can maintain current strategy, force evolution, enforce structured inheritance, induce random mutation, execute full swarm reshuffling, hybrid fusion of strategies, exploration boost to increase randomness, or to convert workers towards a best known strategy. And then how this kind of works out, and then you can see here things like chess, right? So it takes these and it's thinking 5 moves ahead straight up, and then kind of like incorporating a lot of chess strategy within all of this, and then it's utilizing Q learning, has a memory, adaptive learning rates, etc. Right, and then from there, essentially the queen can it chooses like how to rule essentially over the swarm once it gets into that. Right, I'll show you the kind of the full code once we get to the end there, but essentially how it works is like the queen essentially by the end of this has control to say it's going to be like totalitarian or less strict, more strict, etc. And then like the queen, it has one priority, which is to improve accuracy every single round. If accuracy doesn't improve every single round, the queen is essentially tossing the board in the air and doing whatever it needs to do. And then it has memory, so it tosses the board in the air, whatever it needs to do. Okay, this worked, let's do it again. If we have to toss the board in the air again, we're doing it this didn't work last time, and it develops those patterns over time, and it's thinking 5 moves ahead. And then so getting there, right? How do I get there? I start off with these simple experiments. So I define a swarm of agents, and then I define them utilizing Fibonacci-inspired learning updates, just for like a lot of reasons going into the math. Math works out very well with Fibonacci-inspired learning updates and like making swarm agents move via Fibonacci sequences. I don't know why. It just works out very well. I've established that. And then so I go through and I create the workers, and then in this instance, this is the output, right? And so I'm just like trying to, at this point, like, is this going to work? And then so worker 0 used the random strategy and came up with an accuracy. Worker 1 used the hybrid strategy. Hybrid hybrid, and so I'm just each individual agent gets assigned like a different strategy to deploy, right? And then like within this, so there's no essentially like the queen is just essentially monitoring this at this point and then adjusting. So the queen adjusted off of framework, and then so like next step is let's make this more dynamic. Right, and then so I'm adjusting this out, and then let's see what actually happens here. And then a lot of the time, right, the queen's adjusting 5 workers, but it's not actually doing like, so in this instance, I'm getting the queen to adjust workers, but you can see like the queen's adjustments isn't doing anything, right? Like queen adjusted 5 workers, queen adjusted 5 workers, queen adjusted 5 workers, but like we're stagnating again after, so we get some variant. This is again typical with hypervectors and with swarm algorithms, where we get like some variance here in round 1, and then like no variance after that. It's just all like straight up, like it's locked, and it's locked in this instance at 56% accuracy. And so, okay, we want to break that lock, right? And then so that's what I start doing. Like I start giving the queen like more and more flexibility, right? I make the queen essentially like stronger and smarter, and that's like the goal. Like, and so I start incorporating like multi-round learning with meta learning. I start introducing reinforcement learning. I get to Q learning by the end. Like it's Q tables, like all of it, right? Like I want this queen to be a general, and then the queen like has full control to whatever it needs to do in this system. And then we can see that starts to work, right? The queen is at least doing stuff for 4 rounds, but then still, I mean, it's like, whatever does this to make these like swarm hypervectors to converge like this, I don't know, but diffusion, like just where it'll get good, like it's 60% accuracy, right? But then it just keeps like, it's like it will only find its way home to 60% accuracy, and that's going to be what it like wants to be forever, right? And so that's what I'm trying to shake out of this, like get out of that. And then it's just so hard. It's just all iterating on that numerous times, right? Can I do this? And the queen keeps like wanting to just maintain like strategy no matter what. And then so like I get it, and then it's like, okay, I'm getting the queen to make adjustments like on the fly for the individual workers, but the queen just like, it's like not forcing evolutions. And then like finally round 5, it's like, okay, by the end of my simulation, I get it to force 10 workers to evolve. Like, okay, it just throws the board after round 5, right? Okay, cool. But like that's it, like literally the end of the simulation. Like I need it to happen sooner, right? So more iterations, like more, like you can see the code is getting longer and longer and longer with each of these blocks, right? And it's all of the increased code is going towards the queen. Like the worker logic stays the same. It's like, let's give the queen more and more tools. Okay, it's not enough. The queen needs like surveillance mechanisms. It needs worker state tracking. I start like literally like give it modern state tools, right? So the queen started off in medieval times, and then now the queen it's got worker state tracking. It can surveillance the workers at all times, like literally like loyalty assessment, performance analysis, etc. Right? It's like, and then I start giving it ability again, like it can operate tyrannically, like or like operate like a dictator, like a monarch, like, and it has like ways to adjust. It's like full rule and control, right? I'm just giving it more and more levers to pull. And then so that's essentially what we start building out here. And then this is like the full end result that we get from that. And then so what we get, and then so highlighting here what I can do at this point is, so I can get these models at like 92%, 93, 93, 92, 93, 91, 92. So I get 93% accuracy or so across the board through all of this, utilizing this methodology that I've built out here. So 93% accuracy on an agent framework. That's double every other agent framework that currently exists out here on the market currently right now. I'm not utilizing any LLM models. The queen in this instance is not an LLM, and I do that on purpose. The queen is much more akin to like a reinforcement learning algorithm and everything, like a PPO algorithm, pure PPO, right? Because like swarm agents our swarm algorithms are PPO algorithms anyway, naturally. So it all blends together and it all fits together in a nice little package. And I don't rely on LLM models, which is why I can get up to 93% accuracy. Within this, I do have to tune out and build this, right? Like you can't just take my code. That's the one caveat within this. Like with this particular framework, you're not going to be able to just like take my code and not iterate on it whatsoever. Like you're going to have to change this and build upon this to whatever your particular situation is, and build out and improve upon this framework, right? But so this like you are free 100% to do that, all that you like. MIT license. If you need help with that, like if you're a corporate entity and you need help with that, feel free to reach out. Again, I'm showing you proof right here. I can double any other agent framework that currently exists on the market. Any big corporation, I don't care if you're Microsoft, Salesforce, etc. I'm beating you out right now with this framework that I'm open sourcing. Now you can beat me with it if you want, but I developed it, so I know how to fine tune it better than anyone on the planet. So if you want to talk to me about how to fine tune this for your business, I'd be happy to. And if you like this type of content, please like and subscribe. Thank you very much.